geobyte.
Similarly, let's take the another important problem. Okay, look at the screen. It is asking like this: an automobile moving with a speed of 36 km per hour reaches an upward inclined road of angle 30 degrees. Automobile vehicle speed, like car speed. Here, specifically the name of the vehicle not given. I am assuming that automobile vehicle is car. Car is maintaining the velocity v equal to 36 kilometer per hour. It is equal to 36 into 5 by 18. Then 18 two times. 2 into 5 equal to 10 meter per second. Okay. The inclination angle of the road means it is traveling in the inclined road of angle 30 degrees. Its engine becomes switched off. That means engine is switched off. If coefficient of friction mu equal to zero point 0.1, that may be between the road and tires of the automobile vehicle, then how much distance will automobile move before coming to rest? That means after the engine is switched off, what distance the automobile vehicle can be moving in the upward direction? That is the distance I am marking as yes. Understood clearly? An automobile vehicle is moving in the inclined road, right? And engine is switched off. After the engine is switched off, up to what distance the automobile vehicle can be moving? Okay, that is the question. For that, let us take the automobile vehicle on the road, right? Inclined road, right? So here, angle of the inclined road is given 30 degrees. Now look at the contact surface. This is the contact surface. Now let us assume this is the automobile vehicle. Automobile vehicle like car. As you know, normal reaction is developing normal to the contact surface. Contact surface along the plane. This is the normal reaction. And through the center of gravity, through the center of gravity, the weight is acting vertically downwards. This is the self weight of the vehicle with a magnitude mg. Let us mark the angle. This is also 30 degrees. Then this is the mg cos 30 degrees, and this is the mg sin 30 degrees. Okay. Look at the direction of motion. This is the direction of motion of the vehicle with a speed v given 10 meter per second. Since the vehicle is moving upwards, the frictional force is acting opposite to direction of motion. F equal to mu into n. But what is the n? Look at the n value. N equal to this n must be balanced by mg. Mg cos 30 degrees. Okay. Right. N must be balanced by. Okay. Correct. Then what is the frictional force? Frictional force F equal to mu n. In the place of n, mu into mg cos 30 I can write it. Then let us write the energy balance equation. Here vehicle is maintaining the kinetic energy. The kinetic energy vehicle maintained by the vehicle must be equal to mg sin 30 degrees plus frictional force into displacement of the vehicle. Net force multiplied by displacement is giving the net energy. That net energy causing for traveling the vehicle to a distance s. So here kinetic energy equal to what? Half into m into v square equal to mg sin 30 degrees plus f. F equal to what? Mu mg cos 30 degrees multiplied by distance traveled by the vehicle. Here m will be cancelled on both sides. M will be cancelled. Then it is v square. Look at the v. 10 square by 2 equal to sin 30 1 by 2 plus mu value given 0.1 cos 30 root 3 by 2 multiplied by the displacement. Displacement. Then the distance traveled by the vehicle equal to, it is 10 square by 2. I can write 50. 50 divided by zero point 0.5. 1 by 2.5 plus zero point 0.1 by 2 into root 3. Suppose here G is a G can be written outside. G, right, into G. That G you can take 10 meter per second square. Now you simplify it for getting around 8.5 meters. Simplify that value by taking G value equal to 10 meter per second square. That is the answer. That means after the engine is switched off, the vehicle can be traveling to a distance of 8.5 meters. Look at the options. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at the problem. Asking like this. An object takes n times as much time to slide down a 45 degrees rough inclined plane as it takes to slide down on a perfectly smooth 45 degrees inclined plane. That means there are two planes. One is smooth inclined plane. Inclination angle is 45 degrees. Rough inclined plane also maintaining the same angle. But the time required to slide down on the rough inclined plane is n times the time required for sliding down on the perfectly smooth inclined plane. Okay. The coefficient of kinetic friction between the rough plane and the object. What is the coefficient of friction between the rough plane and object? For that, first let us take the smooth plane. Let us take the smooth plane. Smooth plane. Angle is 45 degrees, not 30 degrees. The angle of the plane is 45 degrees. That is the theta. Right now, look at the normal reaction. You know, normal reaction always normal to the contact surface. This is the normal reaction direction. N. Then this is the G. Right. This is the theta. Of course, this is also theta. I can say this is developing two component of accelerations. G cos theta, and this is the G sin theta. G sin theta. Now it is sliding down means initial velocity u equal to 0. Okay. Then let us write the one of the equations of motion, that is S equal to ut plus half at square. Here u equal to 0. Here u equal to 0. Then S equal to half into, you know, this is the acceleration a equal to g sin theta, half into a equal to what, g sin theta into t square. From this, t square equal to 2s by g sin theta. Theta equal to 45 degrees. T equal to root over 2s by g sin theta. That is the time required for traveling or moving down on the smooth inclined plane. Okay. Now let us take the rough inclined plane. This is the rough inclined plane. Let us write it. Rough inclined plane. That rough inclined plane also maintaining the same angle. Look at the same angle, 45 degrees. Here theta equal to 45 degrees. Then again, this is the contact surface. Listen carefully. I am trying to explain the each and every point. This is the normal reaction. Then this is the center of gravity. Through the center of gravity, this is the G. Look at the theta value. This is the theta equal to 45 degrees. This is the G cos theta, G sin theta. Since it is a rough inclined plane, this is the direction of motion. Then the frictional force acting opposite that one, right? Then The frictional gravitational constant is mu into g cos theta. Mu into g cos theta, right? That means because actually frictional force F equal to what? Mu n. This n must be balanced by mg cos theta, right? Mg cos theta. That's why it is taken. Actually, n equal to mu g cos theta, but we are writing the gravity constant in terms of friction. Therefore, net acceleration for this case, let it be a dash. Net acceleration equal to g sin theta, minus coefficient of kinetic friction g into cos theta, cos theta. Then what is the time it is given that t dash equal to n times the t, n times the t. Here t already you have written na. What is the t value? Look at the t value. T value equal to 2s by g sin theta, root over 2s by g sin theta. Then what can be the t dash value? Here t dash value equal to root over 2s by, right, g sin theta minus mu g cos theta, mu g cos theta. Then t dash by t equal to n. T dash by t equal to n. Let us substitute the t dash value. Here it is. Listen carefully. 2s by 2s by g sin theta minus mu g cos theta by t. T is 2s by, t is for under root 2s by g sin theta. G sin theta is equal to n. Now let us cancel this 2s. Of course, g can be cancelled. G can be cancelled. You know, angle for both planes, for both rough inclined plane and smooth inclined plane, angle is 45 degrees only. Sin 45 degrees equal to, as you know, sin 45 degrees equal to cos 45 degrees. Then this sin theta also cancelled. Finally, what we are getting, right? Finally, we are getting root over 1 by 1 minus mu equal to n, or n square equal to n square equal to n square equal to 1 by 1 minus mu. 1 minus mu equal to 1 by n square. Mu equal to 1 minus 1 by n square. That is the coefficient of kinetic friction. 1 minus 1 by n square. Look at the option B. 1 minus 1 by n square. Option B is absolutely correct. Are you following clearly? I am trying to explain the each and every point at your better understanding level. Okay. Similarly, shall I take the another important question? Yes. Look at the another important question. Try to read it clearly. It is asking like this. Two blocks A and B are placed one over other on a smooth horizontal surface. This is the smooth horizontal surface. Smooth horizontal surface. Okay. The maximum horizontal force that can be applied on the lower block. What should be the maximum horizontal force that can be applied on the horizontal block A, so that A and B move without separation is 4. That means maximum force F max is given 49 newtons. The coefficient of friction between A and B, you are asked to decide what is the coefficient of friction. Very simple. This force must be equal to mu into MA plus MB into G. From this, the coefficient of friction mu equal to coefficient of friction between the A and B equal to 49 divided by MA plus MB into G, right? G. This is the let us write the MA value. MA equal to 7 kilograms. MB value 3 kilograms. Let us substitute the values. 49 divided by 7 plus 3 into G. 9.8. 9.8. Then it is equal to 49 divided by 7 plus 3, 10. 10 into 9.98. 49 by 98 equal to 1 by 2. 1 by 2 equal to 0.25. That is the coefficient of friction between the block A and block B. So look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A block A of mass 100 kg resting on another block B of mass 200 kg and is tied to a wall as shown in figure. Look at the block A which is tied to the wall. Which is tied to the wall. Of course, block B is placed on the surface. This surface may be the ground. It is clearly given that mass of the block A 100 kilograms and mass of the block B equal to 200 kilograms. The coefficient of friction between A and B, coefficient of friction between A and B is given 0.2, and that between B and ground, coefficient of friction between the B and ground means surface 0.3. The minimum force required to move the block B is, what will be the minimum force required to move the block B? Block A cannot be moving because block A is tied to the wall. Okay. For that, you are asked to take G equal to 10 meter per second square. That is the question. Okay. For that, as you know, the force must be equal to frictional force developed between the A and B plus frictional force developed between the B and surface. What is the frictional force between A and B equal to, right, mu into mu between A and B, m of A into G. Similarly, frictional force between the B and surface equal to mu between the B and surface into MA plus MB into MA plus MB, MA plus MB into G. Okay, that frictional force F equal to mu AB into MA into G plus mu BS into MA plus MB into G. Right, now simplify it. F equal to mu AB given 0.2, MA 100 into G 10, mu BS 0.3. Look at the mu between the B and S 0.3 into MA 100 plus 200 into G 10. Simplify it. 0.2 into 1000 plus 0.3 into 3000. Simplify it. It is 200 plus 900 equal to 1100 newtons. That is the force to be applied on the block B to move the block B. Okay, look at the options. Option C is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at this problem. Block A of mass m and block B of mass 2m. Look at the block A and block B. Block A and block B. Right? Here this is the block A, block B. Now mass of the block A, MA given M, and mass of the block B given 2m are placed on a fixed triangular wedge by means of massless inextensible string. Look at the fixed, this is the fixed triangular wedge. The wedge cannot be moving. And look at the string, this is the string. It is clearly given, it is massless. Massless and inextensible means rigid. And frictionless pulley, this is the frictionless pulley. Frictionless pulley. Okay, next. as shown in figure. Then problem not completed. Look at this continuation. The wedge is inclined at 45 degrees to the horizontal on both the sides. That is clearly given in the diagram, right? So both surface of the wedge are maintaining the same angle 45 degrees. If the coefficient of friction between the block A and wedge, coefficient of friction between the block A and wedge is 2 by 3, and that between the block B and wedge is coefficient of friction between the block B and wedge is 1 by 3, and both blocks A and B are released from rest. Both are releasing from the rest means initial velocity, initial velocity, velocities of both blocks is 0. Then acceleration of the A. What is the acceleration of of block A is how much? That is the question. Okay. For that, let us go back to the right. It is given that mu between the A and wedge is point. Here it is not point two. It is 2 by 3. 2 by 3, and mu between the B, right, block B and wedge is 1 by 3. Let us cross verify it. 1 by 3, 2 by 3. Absolutely correct. Okay. Then look at the block A first. With respect to block A, this is the normal reaction. This is the weight, that is M or MA, right, into G, developing two component of weights, MA G cos 45 degrees. This is the MA G sin 45 degrees. The same way for the block B. For the block B, weight is acting. This is the normal reaction direction. Normal reaction for the B. This is the normal reaction for A. Listen carefully. Then this is the MB into G. This is the theta equal 45 degrees. This is also 45 degrees. Then it is developing two component weight. This is the MB G cos 45 degrees, and this is the MB G sin 45 degrees. Okay. Now let us decide the frictional force. By the time definitely, since the weight of the block B is more, that block B is trying to move in this direction. By the time block A is moving in that particular direction. Okay. Then frictional force. Let us decide the frictional force. Total frictional force, I can say. Total frictional force, F equal to F between the A and wedge plus F between the B and wedge equal to mu A and W, mu, right? It is MAG, MA into G cos 45 degrees, right? Plus mu between the B and wedge into MB G cos 45 degrees. Now let us simplify it. It is equal to mu AB 2 by 3 MA G, right, cos 45 degrees 1 by root 2 plus Mu between the B and wedge is 1 by 3. MB is 2M. Let me write it. MB is 2M. 2M into G into cos 45. Also 1 by root 2. Let us take another slide. Frictional force equal to total frictional force equal to 2 by 3 M into G into 1 by root 2 plus 1 by 3. Here it is 1 by 3. 1 by 3 into 2M. Mass of the B is 2M into G into 1 by root 2. Now you simplify it. Right, simplify it. For getting it is 2mg by 3 root 2 plus 2mg by 3 root 2. So finally it is equal to 4mg by 3 root 2. That is the frictional force. Okay. Now let us decide the pulling force. Pulling force developed by the B on A. Right. Pulling force is developed due to this mg sine 45 degrees. Pulling force equal to mb g sine 45 degrees. That is no towards right this, but it is acting opposite now. Right, a horizontal mg sine 45 is acting opposite. That's why it is minus ma g sine 45 degrees. Now you simplify it. ma equal to 2m g sine 45 1 by root 2 minus ma is 1 a g 1 by root 2. Simplified. It is 2mg by root 2 minus mg by root 2. It is equal to 2mg by root 2 minus mg by root 2. It is just mg by root 2. Root 2. Now compare the pulling force. Pulling force is mg by root 2, whereas frictional force equal to what? 4mg by 3 root 2. From this I can say that the frictional force is more than the pulling force. Therefore, the blocks cannot be moving. Blocks cannot be moving means acceleration equal to 0. Right? So that is the acceleration of the block A or block B. Acceleration will be 0. Option D is absolutely correct. Since the frictional force is more than net pulling force, therefore the blocks cannot be moving. Right? It is very, very important problem.
Geobyte.